My name is Simana. I'm the VP of Engineering at SumUp. I lead a team of data scientists, machine learning engineers, and software engineers globally. My team is responsible for building product solutions to prevent and mitigate fraud, risk, and financial crime. I look after the risk and compliance business globally for SumUp. So I'm going to start my presentation just by giving a little bit on the agenda, just to prepare you. It's going to be a bit technical, so hopefully it's fine. So I'm going to give an introduction to SumUp. I don't know if many of you know about SumUp. Machine learning, I'm not going to give a huge introduction. I'm sure many of you know about it, and if I have to talk about machine learning, that's going to take a few days. And then I picked up two use cases for that we are in production. One with traditional AI and one with generative AI. In SumUp, we have got more than 15 models already in live and in production making decisions using machine learning. But I have just picked up two topics which hopefully will be useful for you. Okay, so SumUp is a global payment services provider company. We are mainly targeting our small and medium-sized businesses, and we are a global company. We have markets in Europe, in USA, in LATAM, and in Australia. We operate in 36 markets, and we are supporting 4 million merchants globally. We are 3,000 plus employees, and we are a truly global company with 90 plus nationalities who work for us. Okay, so I'm going to give a brief introduction about the SumUp products. You would have seen probably our very popular white card readers that come in various shapes and sizes, probably in the coffee shops or salons, or you might have seen in Wembley Stadium also, because they use those readers. But that's not where we end. We have a number of products. We mainly have two segments that we support, merchants and consumers. So for the merchants, we provide the entire range of products to support their business. So we have the accounting product, invoicing product, all the card present and card not present scenarios. We have also invoicing and lending products as well. For consumer, we have a consumer wallet product and also loyalty products. And then in between, we have other products which are for closing the loop. Okay, I just want to ask before I give an introduction to machine learning, how many of you are using machine learning on your day basis? Okay. Okay, few hands, okay, good. I'm not going, as I said, I'm not going to talk a huge amount about machine learning, but just a few fundamentals so that you can relate to when I'm giving those use cases. So let's start with the definition of machine learning. There are various definitions. So the one that I really like is machine learning is the science of getting computers to learn and act like humans do and improve their learning over time in an autonomous fashion. And that is what I think defines and differentiates machine learning from artificial intelligence. So I'm going to talk about few fundamentals of machine learning. The first fundamental that I want to talk about is learning from data. So for machine learning, what is most important is the data. You need a huge amounts of data to build your machine learning model. You need a lot of input data, and the data is processed. And as a result of training and analyzing those data, the system will learn as part of that processing and analyzing and training. The second part, fundamental, is there are two types of learning, supervised and unsupervised learning. The supervised learning, there is an input data that will be labeled and it will have predictions. So for example, if I show you lots of pictures of dog and I say this is a dog, and I give lots of features of dog and I say this is a dog, the machine will learn that this is what a dog look like. So next time when I feed data around dot, it will automatically say that, okay, this is a dog. So the examples of those are weather forecast, spam filters, which learns from supervised learning. Whereas in unsupervised learning, there is no, the input data is not labeled, and it learns from patterns and structured discovery. So examples of this is, I'm sure all of us do a lot of shopping online. So if you go to the Amazon app, you buy a product, Amazon will tell you, you might like 3 other products that they will promote to you. This is done using unsupervised learning. So they're looking at the pattern, what you buy, your buying history, and based on that, it is giving a recommendation. Okay. One of the very important concepts of machine learning is feature engineering, because to feed the data to the machine learning system, you need the feature stored. And feature engineering is the process of transforming raw data into meaningful features that can improve the performance of machine learning models. And for that, domain knowledge is very important. So if I give an example in the context of SumUp, Normally, there are two types of features, numerical and categorical. So for SumUp, a data that we always use is the total transaction volume. What is the processed volume of a merchant over a period of 24 hours, in the last hour, in the last minute, so that the machine can make the right decision. So that's an example of a numerical feature. Whereas information like race, age group, educational level of the merchants, that are also important information that is fed into the model, but that is kind of a categorical information that is understood by encoding. Okay, the last concept that I want to say briefly is about ML workflow. So it's a huge journey when you start from thinking about that you will have a machine learning model to have any use case that you want to solve to deploying in the model. So the first thing that you need to do is start with the business goal. To understand the business goal properly, without understanding the goal and what are you trying to solve, you should never jump into building the model straight away. Then you frame the model. What's the model? What's the problem it's going to be solving? Once you've done that, you gather the data and you process the data. And then it takes a lot of time. It can take from weeks to months for the model development. Once a model is developed, then you deploy it and then you monitor it. Before you do that, there are multiple parameters that you can look at for the model. Things like area under curve, the true positive rate, and recall are the normal things that are used for machine learning model. And once you've done that and monitored, it will go through a loop and cycle. So based on the monitoring results, you might have to come back to the model, redevelop the model, and train the model again, and deploy it and monitor it. Just so you know that it doesn't happen by magic. Some models can take up to months, I have seen, and some models can be done in weeks. So don't lose your patience. Okay, so I said that I'm going to talk about 2 selected use cases. So let me move on to that. So the first use case, this is using traditional AI that people knew before generative AI became a big hype. This is the use case that I'm going to talk about is online transaction fraud, and how are you preventing online transaction fraud using machine learning. So I'm sure all of us use credit card here, and you know that credit card fraud is a huge problem. Globally, it's a big problem. If I look at the Nielsen report from 2020, roughly $29 billion was the credit card loss in a year. So it's a huge proportion, and it impacts all the credit card issuers and the issuing banks. So how does that happen? So let's say a payment has been done. It could be a card present or card not present scenario, and the payment is a fraudulent transaction. So the transaction has been processed by our system, and then what will happen is a chargeback will come to us. So chargeback is nothing but a request that you and I can actually make a request to our bank saying, I haven't authorized this transaction, or it was a fraudulent transaction, or I'm not happy with the transaction, so please give me back the money. So that is what is called chargeback, and this chargeback can be a huge financial loss for fintech companies like us in SumUp. So we have really been bitten by this problem. And 3 years back, we thought that we'll start using machine learning model to solve this problem. So I'm just going to briefly talk about what is our solution here. So you can see in the middle, there is a fraud detector. Fraud detector is the model that we have developed, machine learning model. It's a third-party model that we have used, and we have trained with our transactional data. There is a transaction checkpoint. This is where the decisions are made, whether the transaction should be allowed or declined. And the machine learning model gets data from the feature store, which gives highly accurate and aggregate data in real time. And as a result of that, and the result of the learning, the fraud detector can actually make a decision within milliseconds. So our model makes decision within 200 milliseconds. And that decision of the riskiness score of the transaction is sent to the transaction checkpoint. There are other decision engines also we use. We use a combination of some rules-based system, some allow list, to combine with the decision of the riskiness score that is coming from the model. And then a decision is made at the transaction checkpoint. So this is how we have deployed the machine learning model. And this has been in use for the last 3 years and has been very good for the business. So I'll talk about the achievements a little bit. So 3 years back, as I said, we had a huge problem in Europe and in Brazil, where we have been constantly getting chargeback, and it was impacting on our bottom line. So we developed this machine learning this model 2.5 years back, and over the 2.5 years, we have seen a huge improvement with the chargeback. So we have, in the last year, there has been a 41% decrease in the chargeback that we have seen, and the chargeback that we are kind of getting is really good. I think probably we cannot go beyond that. There will always be some chargeback that we cannot stop with the model. The other thing that we can do with this machine learning model, we can adjust our risk appetite based on the market segment and the fraud pressure. For example, Brazil is a market where we have a lot of fraud, and if we want to use the threshold for Brazil market, that could be quite different from the threshold that I use in European market. So I have the ability to tweak that in my machine learning model. And also it helps to do basic plug and play when you're rolling out new markets. So we just rolled out to Australia recently, and we've used the same machine learning model, but with a different threshold that we think is suitable for the Australian market. So this model has been very effective and helping SumUp with the bottom line. I'll talk a little bit about the challenges that we faced in building this model. So the first challenge that we had was data availability. So when we started building this model, we had to gather, as I said in the beginning, you have to gather the right set of data, right input data, so that you can actually make a decision in the real time. So how we have solved this is using feature store. I spoke briefly about feature engineering. So feature store is a very important concept in the world of machine learning, because you want to reuse your data. Once you have your data in the feature store, you want to reuse the data. You want to use the same data in multiple different machine learning pipeline. And let's say our data point has changed, so that you know which feature store has to be run. So the solution to all of this problem in machine learning world is feature store. We have two different kinds of feature store. One is an offline feature store, and one is an online feature store. The offline feature store is used for the development of the model. So when you're developing the model, you don't need a huge amount of performance, because it doesn't have to take an action in the real time. So to keep the cost low, we're using an offline feature store, which is not that performant, but it is still taking the right decision. And the online feature store is what we're using in production, which is taking decision in milliseconds. The next problem we had was measurability. I think my previous speaker also talked about metrics and how important are those. And for us as a company who are very much driven by data, it was really important how effective is our model, and how do you know that the model is acting, is taking the right decision or not. So the problem that we have solved this is with control group. So before we deploy the model in live and the model start taking decisions, we use something called control group, where what happens is the model is deployed, but the certain percentage of transaction is only sent through the model, and it doesn't take any decision. So it doesn't decline or accept the transaction, but it only logs the result. And through logging the result, we can see over a period of time how good is our model. And with that, we can say, okay, the model is now performing well, and we are happy to roll this out to production. Yeah, so that's about my first use case, which is the fraud prevention. So it's using the traditional AI. So I'll move to the next one, which is the automated report generation using large language models. So there was a huge hype starting from last year, about generative AI. So we were also quite interested about that. And as I said, AI is not something new for us, because we have been doing this for past 3 years. So I spoke about problem of credit card fraud. Another big problem that fintechs face is money laundering problem. So money laundering is a problem which impacts everybody in the fintech industry, and it's almost like 5% of the global GDP, which is almost close to $80 billion that is gone through the system. So those of you who don't know what is money laundering is basically the process of disguising your illegal activities and illegal funds into legitimate funds. Once you do that, the source of your original fund cannot be traced back. So if it has come from some terrorist activity, some child trafficking, you cannot trace back where the fund has come from. So this is a global problem, as I said, an $80 billion is its impact in a year. So we have multiple machine learning models where we use this thing to monitor this product, because as fintechs, we are legally liable by the regulators that we'll have to monitor all the transaction that passes through our system. So what we have done is just to talk to you about the process first. So the process is that once we monitored all our transactions for money laundering activities, then there's an AML agent who looks into that and looks into if there is any suspicious activity that is happening. If there is a suspicious activity, then we'll have to take an action, which is called a suspicious activity report that you have to generate, and you'll have to send this to the regulatory authority so that they can see that this activity has happened and take the right action following that. So this is a loop that goes through. So what we have done is, this suspicious activity report is a report which is kind of a very repetitive kind of report, and it's very time consuming for the AML agents to write. So we have automated this creation of this suspicious activity report, which is, as I said, it's a regulatory responsibility being a fintech company. So we've used a few tools. So we're using GPT-4 from Azure. This is our own Azure hosted model. And this is quite important for us because we couldn't use the open source OpenAI. Being a fintech company, data security and data privacy is very important to us. So we had to use something like Azure, where we know that our data is protected and will not be used in the internet. We're using online feature store, as I spoke earlier, because we need to get the information of the merchant and their transaction in the real time. So we're using the online feature store. We're using LangChain to wrap the calls, and I'm going to talk about this a little bit later. And then for the web app, we're using Streamlit. Using this, we have built this automated report generation tool, which basically helps to create the report in minutes. It used to take like 25 minutes to 45 minutes to write one report. Now it's happening in 5 minutes. Although there is a human loop, because we wanted to make sure that we don't completely remove the human loop, and there is an agent who is still looking into the report and making sure that the output that has been produced by the LLM is still right and is talking about the same right thing in terms of what are the suspicions. So but there are 2 stages we have done the project. This was done in very quickly. This was actually from the start to finish. We have finished the project in 6 weeks. In the first phase, what we have done is we have the master template of the report, and we are passing data to this, all the historical data, and we have also included the transaction history data. And in the second phase, what we've done is we're using the transactional factual information, and we can see several merchants who have got the similar kind of information who are suspicious, linking of that. That's the information we're using in the second phase. So as I said, it's very important to train your large language model. You have to have the right prompt, and for that you need the right prompt engineering. So you need a structured context to send to the LLM model so that it can take the right decision. So what we have done is we had a lot of historical reports. So these historical reports we have sent to LLM as a prompt context, and we're using MapReduce documents chain. So basically, these documents are quite large, so it cannot be fed to the model because there is a limitation of the token, which is a 8K context. So what we have done is the MapReduce. So the map function, what the map function does is it breaks the document into smaller chunks, and it summarizes those chunks. And then the reduce function is used to create the summary of the summaries so that it creates the final output of the report. Okay, I have time. Okay, so what was the challenge for us in terms of LLM? And I don't know if some of you have faced this challenge already. The big problem that we faced is, how do you know our LLM model is taking the right activity, and is taking the right action? The output that we're getting from the large language model, is it right, or is it fraudulent, or is it, there is a lot of false positive. So what we have done is we have used another large language model to evaluate this large language model, and I think this is something that we have done is completely new. I don't think anybody has done this before, so SumUp is first to do this, and we have also written an article around this. So what we have done is we are basically using another model, and that model is looking at this existing model for the report creation in terms of topic coverage, profile data, supporting facts, facts that are not being invented, and conclusion. And by running this other model on the original model, we are able to see how effective is our model. So if I show you in the screen on the right side, you can see a poorly generated narrative where the topic coverage is 2, the facts saying it's saying 3, check conclusion is 4, which means the scoring of those model is not very good by the second model. But whereas in the left, you see those scores are around 4 and 5, which means the model is actually taking right action, and there is a very less chance of AI hallucination and getting false positive rate. That's it. Thank you.